Alright, the Pythagorean theorem and its converse. So first off, the Pythagorean theorem states that if a triangle is a right triangle, then the sum of the square of the legs is equal to the square of the hypotenuse. And so essentially, what you're used to seeing then is that if you have a right triangle, and C, let's just call C the longest side of that right triangle, and A maybe the shortest side and B the medium length side, we know then if it's a right triangle that A squared plus B squared equals C squared. So the converse of that essentially is this. If you have a right triangle, or if you have A squared plus B squared equals C squared, then you have a right triangle. A little abbreviation there. So if A squared plus B squared equals C squared, then it's a right triangle. And you can take it even further still. So if C squared equals A squared plus B squared is a right triangle, so we have basically this, where this is a right angle, okay, then we also know that if C squared is greater than A squared plus B squared, we have an obtuse triangle. And if C squared is less than A squared plus B squared, we have an acute triangle. And acute, you make sure you understand what right, obtuse, and acute mean. Right means you have, this would be a right triangle. An obtuse triangle means you have one angle greater than 180. And an acute triangle means all the angles are less than 90, which I didn't do so hot there. So guaranteed that one is acute. All angles are less than 90. Now, how does this work in practice? So let's try it out. So let's say we had a triangle that was 2, 3, and 4 inches long. Okay, what kind of triangle can we make? Well, 4, the longest side is always C. And then the other two, it really doesn't matter what you do, but those are A and B. So I'm going to say 4 squared. We're not sure if it's equal or not. Equals 2 squared plus 3 squared. Well, 4 squared is 16. 2 squared is 4. 3 squared is 9. 9 plus 4 is 13. It's greater than. So in this case, if you had a 2, 3, and 4 triangle, we'd have an obtuse triangle. If you had a triangle that was, say, 2 centimeters, 3 centimeters, and 4 centimeters, it would be obtuse. All right? So let's try a different one. Let's say we had a 3, 4, and 5 centimeter triangle. Okay, again, 5 is the C. So longest side's always C. So 5 squared, we're not sure what it is, equals 3 squared plus 4 squared. Well, 5 squared is 25. 3 squared is 9. 4 squared is 16. Well, 9 plus 16 is 25. So if you add these two together, you get 25. Well, 25 is the same as 25. So 3, 4, 5. So something that's 3 centimeters, 4 centimeters, and 5 centimeters is a right triangle. It doesn't matter centimeter. It doesn't matter the units. It could be inches, feet, yards, whatever, miles, kilometers, whatever the length you want to choose for that. If you have a 3, 4, 5, it's a right triangle. All right, and this one's a little different. So let's, 3, 4, 5 worked. So why not 2, 1, 2, 3? Well, believe it or not, this doesn't even make a triangle. So if you have a 1, 2, 3 triangle, and that's usually the first thing you check is, can those lengths even make a triangle? Let's say you have 3 here, 3 miles. Okay, and we wanted to attach a 1 mile piece to it and a 2 mile piece to it. Well, that wouldn't be 3 miles, and we need to make it a little longer. And so maybe it looks something like this. Okay, what happens is, as you swing these down to meet, what they end up meeting is right on the line itself, because 1 plus 2 equals 3. So 1 mile here plus 2 miles here equals 3 miles here. So you end up with a straight line. They do not form a triangle. So that's kind of a trick question for you. So that one's not a triangle. And something to look forward to, or look for, is the triangle inequality theorem. So finally, let's say you had a triangle that was 6, 6, and maybe 9. Okay, so 6, 6, and 9 inches, for instance. So if we do the converse of the Pythagorean theorem to that, 9 is the c, so it'd be 9 squared. We're not sure if it's greater than or less than. 6 squared plus 6 squared. So 81 for 9 squared. This would be 36 plus 36, which was 72. And this is 81, greater than. So if 81 is greater than 72, again, we've got another obtuse triangle. So the triangle looks something like this, where this is 6, and this is 9. And this angle is more than 90 degrees. So this is just an example of the converse of the Pythagorean theorem and how you can determine what type of triangle you have based on the 3 sides. So I hope this helps. Best of luck. See you next time.